So the homework question was to carry on with the cube problem. We found that the flux through the front face was 200 newtons per coulombs times meters squared. Now we want to find the flux through each following face. So we'll do the back face next. Let's remember a few things. Our electric field vector is given by this expression. So our electric field is 20,000, or 2 times 10 to the 4, in the x part, plus 2 times 10 to the 4 in the z part. So that makes this our ex, this our ez, and our ey. We don't have a y part, so ey equals 0. So there's our components of the electric field. To calculate our flux through the back face, we're going to do our electric flux equals E dot A, which means we multiply all the components and add them up. Ex Ax plus Ey Ay plus Ez Az. Now we need our area vector for the back face. For the front face, the area comes straight out, points in the z direction. For the back face, it would point straight out the opposite direction, the minus z direction. So for the back face, the area vector is the length, 0.100 meters, times the width, 0.100 meters, times the direction, which is going to be minus k. So that would give us an area vector of minus 0.0100 k hat. This is in the k direction, the z direction, so this is our az. So if we're calculating our flux, we'll do Ex times Ax. Ax is 0, so this term is gone. Ey times Ay. Ey is 0, so this term is gone, and we're left with Ez times Az. Ez is 2 times 10 to the 4. Az is minus 0.0100, gives a net electric flux of minus 200 newtons per coulomb times meters squared. You might notice that's the same magnitude and opposite sign as through the front face. Okay, next we'll do through the top of the cube, so the top face of the cube. Let's look at our area vector. Area points straight out of the face. There's our area, points straight up, so this one is going to be in the j direction. So the area is equal to 0.0100 straight up, so j. This is our y component, ay, so the x and z components this time are 0. So our net electric flux is Ex plus Ey plus Ez. The x component of area is 0, the y component of electric field is 0, and the z component of area is 0. So our net flux through the top face is 0. Our bottom face will turn out to be essentially the same. The only thing that's different is our area vector, instead of pointing up, points down. So our area is minus 0.010j, and that's still our y component. When we calculate our flux, Ax is 0, Ey is 0, Az is 0, so our net electric flux turns out to be 0. Next, let's do the right face. So our area vector will point straight out of the right face. That's in the x direction or the I direction. So our area vector is 0.0100I. There's an x component, means the y and z components of our area are 0. So our electric flux is Ex Ax plus Ey Ay plus Ez Az. Ex is 2 times 10 to the 4. Ax is 0.100. Ey is 0, so that term is gone. Az is 0, so that term is gone. So we're left with 2 times 10 to the 4 times 0.01 to give us plus 200 newtons per coulomb times meters squared. So there's our flux through the right face. Now to finish, we'll do the flux through the left face. The area vector through our left face points to the left. That's the negative x direction. So the area is minus 0.0100I. That's the x component. Our electric flux will be Exax plus Eyay plus Ezaz. equals our x component of electric field is 2 times 10 to the 4. Our x component of area is minus 0.0100. Our EY is 0, our AZ is 0, so our net electric flux through that face is minus 200 newtons per coulomb times meters squared. The next part of the problem, the homework question, said calculate the net flux through the box. So the net flux is each of those individual fluxes added up. So net flux is the flux through the front face, 200, plus the flux through the back face, minus 200, plus the top and the bottom, a couple of zeros there, plus the left and the right, 200 and minus 200. So then we ask the question, can this tell us anything about what's in the box? Well, what we know is that the net flux tells us the total number of lines which enter or leave through a closed surface. If there's no net flux, then there's no net number of lines leaving or entering the surface. So we know that there's no net flux. So this is just like the problem we had in class where all the lines that went in also went back out. So if there's no net flux, there's no net charge. So whatever is inside that box has got to be electrically neutral.